The following video is the Zoom presentation of a MassDEP UMass Drinking Water Small Systems intern project on wastewater treatment and disposal by Douglas Drenick and Patrick Acer. The MassDEP UMass Small Systems intern program is funded by a US EPA Safe Drinking Water Act grant to MassDEP in support of small drinking water systems throughout Massachusetts. This collaboration began when MassDEP's Yvette Pisa, Michael Maynard, and Art Screpidis saw opportunities for drinking water community involvement and operator training with students of UMass under the leadership of Professor David Reckhow, Professor John Tobiasen, and research engineer Patrick Whitbold. Previous intern projects have worked on lead in schools, small system assistance, operator certification, and other current drinking water topics such as PFAS. MassDEP would like to thank all of our partners on these projects, including the US EPA, Mass RWA, FERCOG, RCAP, and the UMass Group, especially Professor Reckhow, Patrick Whitbold, and the student interns. They've done hard work on this and all their other drinking water projects.
We did our project on wastewater sludge treatment and disposal. So the purpose of this project is we sort of wanted to discuss the impact of sludge disposal on small drinking water systems. And mostly we were looking at the impact of leaching and runoff on drinking water, and then surface water contamination, because more than half of Americans rely on surface waters as their primary source of drinking water. And then the three goals we came up with is minimizing the impact of sludge disposal on drinking water for small systems, both environmentally and economically. And we wanted to identify sort of the primary different methods of local sludge disposal in Western Mass, their environmental impact, and then the importance of being deliberate with sludge disposal decisions. And then also we just wanted to propose different strategies to increase the sustainability of this process in both Franklin and Hampshire counties. So to start, what wastewater sludge is, it's essentially the solid residual left over after wastewater treatment. And then biosolids are treated sludge that can be utilized for things like land application. And there are different categories of biosolids with different permits and different sort of regulations surrounding them on where you can apply them. So with history of sludge management, so prior to 1972, typically in the Northeast at least, we were just dumping sludge in the ocean, which obviously presented some problems with throwing sludge with high levels of BOD and COD into the ocean. Obviously, this was pulling out high levels of oxygen, degrading ecosystems. So we came to our senses and realized this was probably not a good thing to be doing. And then we kind of came up with like 5 main reasons why sustainable sludge management is important in Western Mass. We want to protect ecosystems, utilize these nutrients for land applications through utilizing biosolids as opposed to, dumping sludge just in a landfill or incinerating it. We want to prevent contamination of drinking water, protect human health from different contaminants, and then ultimately reduce greenhouse gas emissions.
All right, so some potential impacts that poor sludge management can have on drinking water is eutrophication, which is basically where nitrates and phosphates somehow get into surface water, which promotes excessive growth of phytoplankton, which can be very damaging to ecosystems and even destroy keystone species and create leaching and other stuff. So then we also have leaching with landfills, which can contaminate drinking water, as well as heavy metals and dioxins and a lot of other airborne toxins that are created from incinerators that can impact surface and groundwater. So next we have the 4 types of sludge handling, which will start with sludge thickening, then sludge gets stabilized and conditioned, then dewatered, and then finally disposed of. So we'll start off with sludge thickening, which basically there are 3 main types of sludge thickeners that are used, which is a gravity thickener, centrifugal thickener, and a dissolved air flotation thickener. And a gravity thickener is basically where solids are settled based on density where higher density solids are removed to the bottom, like you can see in this image here, and lower density solids are basically maintained and removed through later processes. Then we have like a centrifugal thickener, which basically uses centrifugal forces to separate solids into very small particles and remove them. And then we also have a dissolved air flotation thickener, which creates air bubbles with dissolved oxygen to effectively float onto the top and remove suspended solids. So then we have sludge stabilization, which is basically where anaerobic digesters create stable byproducts through bacterial fermentation. And ideally, these byproducts, methane, carbon dioxide, ammonia, can be recycled for energy use. And aerobic systems also, they create stable byproducts in the presence of oxygen, as well as alkaline stabilization is a process that's utilized to maintain pH values. And then sludge can also be conditioned with chemicals in preparation for dewatering, which is the next process of sludge processing. So with sludge dewatering, there are three main types that are used, and first one is the centrifuge, which is use high rotational speeds, kind of just like with sludge thickening, to separate components of sludge based on densities, just like in this diagram down here. There's the middle portion spins at a high velocity, which forces sediments to be pushed outward and moved from the water. So then we have the belt filter press, which utilizes flocculation and compression to separate sludge, as well as the traditional plate and frame filter press, which uses either plates or several cloth filters to dewater sludge. And then finally we have sludge disposal, which can be used in three main ways. As Pat said before, we used to simply just dump it out into the ocean, but now we use landfills, incineration facilities, and land application. So first we'll talk about landfills, which you got the pros and cons of landfills, which the pros, I'll say, is oftentimes there's no permit needed, and it can recycle methane optimally, where it produces methane, but hopefully you can reuse that for other energy. And it has a lower cost compared to some other methods of disposing sludge. But the cons are that it increases the generic output of methane by a substantial amount and creates leachate with an increase in a lot of other pollutants, as well as greenhouse gas emissions, and reduces space for waste. So then we'll move on to incineration facilities, which are basically where sludge is just burned after it's treated, and a lot is released into the atmosphere. So the pros is we got a very low cost, and it maintains more landfill space, and it reduces risk to our water sources. But our cons is that it again has high greenhouse gas emissions. This time there's a lot of heavy metals and a lot of other airborne pollutants can be released, with a lot of CECs, which is contaminants of emerging concern, can also be released. Also, there's a lot of high costs associated with trucking to incineration facilities, which happens to be what we do in Amherst.
Hey, Doug, thank you. I'm going to have you skip to slide 19, just for the sake of time. Doug or Pat, go to slide 19.
Okay, so we interviewed a wastewater treatment operator named Andrew, and he basically just told us all about how sludge was treated in Amherst. So basically we get it from primary clarifiers and waste activated sludge. Then we use a gravity thickener that, it has storage of up to 60,000 gallons. Wastewater treatment typically ships out 18,000 of thickened sludge to an MDC plant in Hartford, Connecticut, which is an immense expense, and that's the only one contract that we have in Amherst. And then other Franklin and Hampshire County wastewater treatment plants go to the Upper Blackstone Water Pollution Abatement District. So then on the next slide we have we talked about issues that most small systems usually only have one contract that trucks out waste, so it would be very essential to have other contracts, especially during a time like now, during a time of pandemic. And you know, rising costs are pretty much just keep going up and up, and we don't know what to do about it. And then we talked about the need for an anaerobic digester in Amherst or in a neighboring town in Franklin County, which could, you know, have a very large impact on the you know, on the environment and costs and a lot of other stuff in Franklin County.
Yeah, so options for Franklin County is they can continue with the status quo, which is incineration. And the issue with this is, as you know, more local facilities close, like the Montague process just recently closed. Now Greenfield is having to truck out their sludge daily. This is like 2 to 4 trucks all the way across the state. So we're facing increasing costs there and increasing trucking related emissions. Just in 2020, they estimate the cost to be $540,000. And with an anaerobic digester, we'll see lower greenhouse gas emissions. We'll actually be utilizing valuable nutrients in biosolids, better stabilizing the sludge to reduce the risk of it contaminating things like groundwater. And it is a large upfront capital investment, millions, but ultimately, I think it's a good investment and will ultimately save Western Mass a lot of money. Yeah, so this is just going through some of the expenses. As you see in Greenfield, which is a town in Franklin County, in 2016, their trucking costs for disposing of sludge was $168,000. By 2020, it's up to $540,000. So we just see that increasing more and more. And an anaerobic digester is $4 to $7.5 million in Franklin County. There's a potential for federal grant money if this becomes a regional digester. So ultimately, I think within a decade, we'll end up saving money by making this large upfront capital investment. So we came to the conclusion that an anaerobic digester is pretty essential for a sustainable future in Western Mass in terms of disposing of sludge. And that's what we got.
Thank you guys very much. Just in the sake of time, one question, anyone?
So one of the things that has happened recently is PFAS contamination in sludge. I know up in Maine they had an incident where they had PFAS application on a farm and it got into a public water supply, you know, from the sludge. So I think that might be another issue that you guys are going to have to watch out for, as far as land application.
Right, and that's the same idea with those CECs, things like pharmaceuticals and endocrine disruptors. They're not really regulated to.
Well, the problem with PFAS is going to be regulated.
Right.
Thank you, Bob, for the question. It's a very good point. And I just want to say quickly, Doug is a computer science major and Patrick is a public health major, so 2 non-civil engineers that work at our Water and Energy Technology Center at UMass. And it just goes to show you that the cross-disciplines of backgrounds can all still be very applicable to water treatment.